New insights into lava planets, evolution, atmospheres, JWST observations. Imagine living on a planet where the ground flows like liquid and the atmosphere is a toxic brew of evaporated rock. The extreme alien worlds called lava planets. These superheated rocky exoplanets orbit stunningly close to their host stars, completing a full revolution in less time than a single Earth day, while suffering surface temperatures so intense they turn solid stone to molten oceans and gaseous plumes. Here's what makes them so scientifically fascinating, and why they challenge everything we thought we knew about planetary evolution. Lava planets occupy an extreme niche in our galaxy. Unlike the rocky worlds we see in our solar system, these furnace-like planets are perpetually dulled on one side, thanks to tidal locking, like a cosmic game of peekaboo with their star, and roasted on the other. The effects are so severe that even silicate rocks, the building blocks of Earth's crust, break down into liquid and vapors, creating a world that's more volcano than evening walk. A new study from Bukhari and colleagues offers the first theoretical roadmap for understanding how these cosmic kilns evolve over billions of years. By simulating the complex interplay between their scorching surfaces, partially molten interiors, and escaping atmospheres, researchers uncovered a surprising truth. Lava planets may follow one of two evolutionary paths. The young and the restless. These freshly formed lava planets could have interiors completely melted, liquid metal and rock flowing beneath their vaporized surfaces. At this stage, their atmospheres would hold molecular clues about the planet's entire composition, like a period archive of its initial formation. But this wild child phase doesn't last forever. Heat slowly escapes from the interior, cooling the planet's core until most of it solidifies, leaving only a thin mantle of lava oceans on the dayside. During this mature phase, the atmosphere becomes chemically altered, losing heavier elements like iron and sodium as they sink back into the solidifying crust. Here's where astrophysicists get divided. Could we actually observe this phase transition? Enter the James Webb telescope. If JWST can detect atmospheric signatures of these older worlds, perhaps by measuring how elements are depleted compared to their younger counterparts, it would mark a landmark shift in exoplanet science. Instead of snapshots, we'd gain moving footage of planetary evolution. But here's the controversial thought experiment. What if solid isn't always solid? On these planets, night-day temperature gradients could keep the backside surface geologically active, even as the dayside hardens. Why does this matter? It challenges our primal assumptions about how planetary interiors cool and lock themselves into fixed states. The study highlights a fundamental connection. While lava planets' chemistry might seem altogether alien, the processes at play, melting, vaporizing, elemental partitioning, mirror those seen in Earth's mantle and crust, just amplified a millionfold. So studying these extreme worlds isn't about weird science. It's about understanding the universal rules of rocky planet formation. Now, we invite you to weigh in. Would you prioritize studying the dynamic, fully molten stages of lava planets, or focus on their older, chemically evolved counterparts? The research not only explains strange new worlds, but offers a lens to view our own solar system's evolutionary toolbox. James Webb Telescope, unveiling the secrets of lava planets' mysterious chemistry. Imagine a world where the surface temperature is so hot that it can melt rock, creating a sea of molten lava that stretches as far as the eye can see. Welcome to the mysterious realm of lava planets, where the rules of planetary science are pushed to the extreme. These scorching hot worlds, some of which are no larger than our own Earth, orbit their stars at such close proximity that a single year lasts less than a day. The conditions on these planets are so alien that they challenge our current understanding of how rocky planets evolve over billions of years. But here's the fascinating part. It's precisely these harsh environments that make them ideal for studying the evolution of rocky planets. By exploring these extreme worlds, scientists can gain valuable insights into the processes that shaped our own planet, as well as other potentially habitable worlds. But how do we unlock the secrets of these mysterious lava planets? A groundbreaking study published in Nature Astronomy has introduced a powerful new approach for understanding these planets. By combining geophysics, atmospheric science, and mineral chemistry, the researchers have developed a framework for decoding the molten worlds. According to Charles-Édouard, a physics professor at York University and lead author of the study, lava planets are in such extreme orbital configurations that our knowledge of rocky planets in the solar system does not directly apply. Using advanced numerical simulations, the researchers identified two extreme interior states. Younger lava planets remain fully molten, with heat circulating efficiently and their atmospheres reflecting the planet's overall composition. But as they age, they undergo a process called chemical distillation, where elements separate based on their physical properties. Heavier elements such as magnesium and silicon tend to remain in liquid or solid phases, while lighter ones like sodium and potassium migrate into vapor. This continuous cycle of melting, vaporizing, and solidifying profoundly reshapes the planet's outer layers. And this is the part most people miss. These processes, though greatly amplified in lava planets, are fundamentally the same as those that shape rocky planets in our own solar system. On Earth, similar mechanisms have left chemical imprints in ancient lava flows and planetary crusts. But on lava planets, these processes are ongoing and dramatically accelerated by their extreme heat and atmospheric loss. The study also reveals that magma oceans on lava planets do not freeze quickly like those on young planets in our solar system. Instead, they persist for billions of years, creating long-term chemical separation between vapor, liquid, and solid phases. But here's where it gets controversial. The researchers are using the James Webb Space Telescope to test their bold predictions. With 100 hours of observation time secured, the team will use the telescope's advanced infrared sensors to study the atmospheres of these planets in extraordinary detail, detecting whether elements such as sodium and potassium are present. Their detection or absence could reveal whether a lava planet is still molten or has transitioned into a more stable, solidified state. As Bucare notes, if we can observe and distinguish old lava planets from young ones, it would mark an important step toward moving beyond the traditional snapshot view of exoplanets. The lead observations will be conducted by Professor Lisa Dang of the University of Waterloo, whose team aims to connect atmospheric data directly to the internal dynamics of these exotic worlds. These insights could revolutionize our understanding not only of lava planets, but of rocky planet evolution in general, including the processes that shaped early Earth and other potentially habitable worlds. So, what do you think? Are lava planets the key to unlocking the secrets of planetary evolution? Share your thoughts in the comments below. The tidal locking of lava planets creates another fascinating phenomenon. A sharp contrast between their scorching daysides and frozen nightsides. Powerful winds generated by this temperature difference sweep vapor and heat around the planet, redistributing materials between hemispheres. Earlier models examined these winds, but largely ignored how molten rock interacts with the solid mantle beneath. The new study addresses this gap by using three-dimensional simulations to track how rock-forming elements like magnesium, silicon, and iron behave in different states. As we continue to explore these mysterious lava planets, we may uncover even more secrets about the formation and evolution of our own planet. The question is, are we ready to challenge our current understanding of planetary science? and embrace the extreme worlds that await us? Unveiling the dark secrets of lava planets, space research insights. Unveiling the enigma of lava worlds, a journey into the unknown, cosmic chronicles. Imagine a realm where molten lava oceans blanket the surface, a scorching landscape forever locked in a celestial embrace with its star. This isn't a scene from a sci-fi epic. It's the reality that astrophysics professor Dr. Lisa Dang and her international team of researchers are delving into. Their quest? To unravel the mysteries of lava planets, a class of exoplanets that orbit perilously close to their host stars, with one side perpetually bathed in searing heat, and the other shrouded in heat. In a groundbreaking study led by Dr. Charles-Édouard from York University, Dang and her colleagues proposed that these planets form as entirely molten spheres, with a deep magma ocean covering their entire surface. Over time, the planet's dark side cools and solidifies, a process that could hold clues to the planet's interior evolution. And this is the part most people miss. To test these theories, Dang's team secured a coveted opportunity: observation time on the James Webb Space Telescope, JWST, a marvel of modern astronomy designed to peer into the cosmos with infrared vision. The JWST, a space telescope renowned for its infrared astronomy capabilities, will provide Dang and her team with unprecedented data on 5 lava planets. This data will be collected over each planet's yearly cycle, which, in these cases, is a mere few Earth hours. By capturing the planet's rotation in its entirety, researchers aim to create heat maps that could reveal the planet's internal dynamics. The approval of their observation request was a significant milestone, marking a leap forward in the study of these enigmatic worlds. Every image we capture is a snapshot of a moment in time, but it's the story behind each snapshot that truly fascinates me, Dang muses. The data from the JWST will offer a window into the lava planets' secrets, allowing researchers to piece together their history and evolution. For each of the 5 planets, the JWST will provide a comprehensive dataset, enabling Dang and her team to observe both the illuminated and shadowed sides over a full rotation. This will be crucial in understanding the dark side's mysteries and gaining insights into the exoplanet's interior evolution. Starting in 2026, Dang and her team at the University of Waterloo will take the lead in analyzing the datasets as they are received from the JWST. The 5 planets they are studying vary in age, providing a unique opportunity to observe these exoplanets at different stages of their life cycle. As each dataset arrives, the team will meticulously dissect it, challenging their predictions and formulating new ones. They are particularly interested in how the planet's heat budget and composition change over time, whether the magma oceans ever shrink or solidify, and what molecules are present. Any unexpected findings will be a bonus, fueling further research and discovery. This data will be the most detailed Dang has ever worked with in her research on lava planets, and she is eagerly awaiting its arrival. The insights gained could revolutionize our understanding of these exotic worlds, potentially revealing new aspects of planetary science. As Dang and her team embark on this ambitious project, they invite the scientific community and the public to join them on this journey of discovery. What secrets do these lava planets hold? And how will they challenge our understanding of the universe? The answers may surprise us all.